Biostatistics. Now, this is a wonderful concept and study that is very important for those dealing with life, that is health sciences or health related sciences. In an introductory approach, I would want us to look at the definition or the introduction to this concept of biostatistics. We say that health sciences have a lot of data that need to be processed to drive some important information for life. Okay, the process involves mathematical or statistical methods, thus the name biostatistics. Okay, or what others call life statistics. Biostatistics is concerned with collection, organization, summarization, and analysis of data to make inferences, that is, conclusions, deductions that are related to the process. Now, statistics have several branches based on application, e.g., medical statistics, or what we call biostatistics. Now, if you look at this, we started by defining biostatistics and involved terms like data and so on and so forth. So, trying to talk about data, this is basically raw facts and figures, which are of course numbers, okay, obtained largely by counting, e.g., number of children with nutritional problems, or by measurements, that is heights of a group of expected mothers, for example. In other words, these heights can only be measured, you cannot count heights. And number of children can only be counted, you cannot measure number of children. Now, other data sources include analysis of records, surveys, experiments, reports like what we have from health organizations. Okay, and records may be pre-existing records or what we call secondary records, which had been collected earlier or taken during health processes. Now, variables, on the other hand, refers to object, characteristic, property that can have different values. Okay, a quantitative variable can be measured and has numerical value, while a qualitative variable actually refers to an observation. Okay, has a property of the inability to be measured and can be sorted into categories. So it's more of what people infer from an observation. Okay. Now, a random variable cannot be predicted. That's a property of, or what we can use to describe random variables. You cannot predict them in advance because it arises by chance. No one can give a pattern for chance, but unless you get to the levels of doing probability studies and so on and so forth. Random variables can be discrete, that is whole number values, or continuous, that is when we're dealing with ranges. When someone involves a conclusion which involves a range, or talking about some bracket of data, therefore you are referring to continuous data and not discrete. Okay, now a population is collection or set of all the values that a variable may have. Okay, a sample, on the other hand, is part of the population. Now, a statistic, which is a descriptive measure computed from data of the sample, while a parameter, trying to compare with what you have as statistic, is concerned with the population. We are saying this is a descriptive measure computed from the data of population. This is concerned with sample. Now, variables with just two levels are called binary variables, like in the cases we have male, female, though of late governments are accepting another gender referred to as intersex. Now, we also have alive or dead, okay, present or absent. Those are binary variables, and many others which you can tell during the time when you are reading this. You can also give your own examples. Now, we have scales of measurements that are involved in biostatistics. We have nominal scales, that is where categorical data has been categorized, and numbers has been used to give used as identifiers. Okay, like 1 can be representing male, 2 for female, so you only use the values, and then the one who is trying to make conclusions can use those values to know what they stand for. Then ordinal scales refers to an ordered series of relationship. That is, when you're talking about first, second, third, in trying to describe your data or information obtained from the process of analysis, this is now a scale which is known as ordinal scale. Now we may have interval scales. This is more of reference scale. A good example is what we realize in temperature scales. That is a scale that involves a reference point where we have 0 and we can have negative, we can have positive values on that same scale, and this is actually of in terms of an interval with respect or with reference to 0, which is for the case of temperature. Now ratio scale is more of a comparative scale, yeah, where measurements focuses on equality of units. Someone would talk about some grams per milliliter, per there symbolizes the ratio aspect. Grams per milliliter. You can talk about various number of entries per period of time, and so on and so forth. So these are very important things to define, even as we want to get into study of biostatistics. And we can look at methods of data collection, tabulation, and presentation in our next study. I will remind us to subscribe so that when we get to this, you can get notified early enough. Thank you, and I wish you the best.